Good morning to one and all. In today's session, we are going to see the delete operations on the double linked list. In the previous session, we have seen the insertion operations on the double linked list. We have seen the different operations like inserting a node at the starting of the linked list and inserting a node at the ending of the linked list, inserting a node after a given node, and inserting a node before a given node. We have seen this particular thing in the last session, inserting a node before a given node. We are inserting 40 before 20. For that particular purpose, what the operations that we have seen, we have taken this as a pointer and we have taken this as a pointer of previous, and we have performed the operations on the left hand side first, that is new node of previous equal to PTR of previous, PTR of previous of next equal to new node, and the new node of next equal to PTR, and PTR of previous equal to new node. And we have seen the algorithm like this. We have read the value before which we have to insert, and we have taken the pointer at the starting, and we have gone to that particular node where we have to do the activity. In the middle, if the PTR is becoming as a null, that means the element is not found to insert, so we are displaying the element cannot be inserted. Then we have performed these four operations on that particular node, what we have seen. The programmatically also we have seen the things that we are doing here. We are reading the value, we are creating the new node, and we are finding out the value before which we have to insert, and we are starting the pointer at start. And while the pointer of data is not equivalent to value, we are going to that particular node until pointer equal to pointer of next. If the pointer is equivalent to null, we are displaying the element not found. Then we are performing these four activities that we are doing. And now we will see the deletion operations. The four deletion operations that we are, three deletion operations that we are having are deleting a node at the starting of the double linked list, deleting a node at the end of the double linked list, and deleting any node in the double linked list. At first, we'll see deleting a node at the starting of the double linked list. So we'll consider the pointer as a starting only. That means start is currently pointing to the pointer. Now I want to delete this particular node. When I want to delete that particular node, two links I have to remove. The first link was start is pointing to this pointer, and the second link is the pointer is pointing to the second node. These two links that we have to remove. This link is the second node of the linked list, double linked list is pointing to the first node. So to remove that particular thing, what we are doing was the start of next of previous. Start of next is this particular node. The previous of the particular node is once again this particular thing. That is, this is the link that I want to remove. So that is, this is actually the start, and this is start of next. Start of next of previous is this particular link. I am removing that particular thing and I am placing that as a null. That is, I have removed this particular link. Then I want to remove this particular link and I want to place the second node as a starting. So that's why the start is not the first one, start is the start of next, or pointer of next we can write. And we are removing this pointer, that is free pointer. These are the operations that we are performing for removing the starting of the linked list. So pointer is pointing to the start. So now start of next of previous is made as a null, start is made as a start of next, and we are removing that pointer, free pointer, that we have written as a pointer. We have taken the struct node pointer, and these are the operations that we have performed on that particular thing. And the next operation is deleting a node at the end of the double linked list. I want to delete the last node present in the double linked list, that is 9. So we'll take an example. We'll see how we are doing that particular thing. Now I want to go from start to this particular 9. For that particular purpose, the pointer is placed at the starting of the node, and I have to reach to the ending of the node. Similar to the single linked list, to go to the last node, we are having the concept that pointer is starting at start, and while the pointer of next is not equivalent to null, I am going to the next node. So see here, I am starting here, start is equivalent to pointer. Is the pointer of next is equal to null? No. So I am going to the next node. That is pointer is going to the 3. Is pointer of next is not equivalent to null? Yes, it is not equivalent to null. So pointer is going to the pointer of next. Next, is the pointer of next is not equivalent to null? Yes. So pointer is going to the 7th one. That is, we are incrementing the pointer. So is the pointer of next is not equivalent to null? Yes, it is not equivalent to null because 8 is present. So I am checking, is the pointer of next is not equivalent to null? Yes, it is not equivalent to null. So I am going to this particular 9. That means pointer is now pointing to this 9. Is the pointer of next not equivalent to null? No, pointer of next is equivalent to null. That means this is the last node that we are having. So when we are having this as a last node, I want to remove this one. So for that particular purpose, I can do that activity, simple activity as free of pointer. But when we are removing the free of pointer, there is a problem of dangling reference here, because when we are freeing this particular pointer, there are 2 pointers that we are not removing, these 2 pointers. For this particular purpose, I can do a simple activity that if this is a pointer, this is the pointer of previous. So pointer of previous of next, I can make it as a null so that this link can be removed. When we are freeing this particular pointer, anyhow this pointer will be removed. Okay, that we'll see by using an example. See here, suppose consider that I am removing the ending of this one, 30 is that one. So this is the pointer, this is the pointer of previous. Now I want to remove these 2 links and I want to free the memory that has been given for the 30. For that purpose, what we are doing, if this is the pointer, the previous node is pointer of previous. This node's next is pointer of previous of next, that is this particular pointer. So pointer of previous of next, we are making that as a null. That means this link we are removing. And this pointer of previous is pointing to this one. This can also be made as a null. There was no need of removing this particular pointer. By default, when we are freeing this pointer, this will be removed. Or you can write it as a pointer of previous equal to null also. But the basic thing was, there was no need of removing this particular pointer, because when we are freeing this one, this will be removed automatically. See here, the pointer is starting at start and I am repeating the step 3, that is pointer equal to pointer of next until pointer of next is not equivalent to null. That means pointer after the 3rd step, it will be reaching to the ending of this one. At that particular point, what we are doing? Pointer of previous of next. Pointer of previous of next, this pointer we are removing. Pointer of previous of next we are removing and we are making it as a null, and we are freeing that particular pointer, and at the end we are stopping this particular algorithm. So as a function wise also we are writing the same thing. I am taking the pointer, it is starting at start, while pointer of next is not equivalent to null, pointer equal to pointer of next. After this particular step, the pointer is present at the ending of the linked list. Then we are doing the previous node of the pointer is pointer of previous. The next pointer is made as a null and we are freeing this particular pointer. The output can be displayed by using this display function. So this is about the deleting a node at the ending of the double linked list. Now we will be seeing deleting an intermediate node, that is any node in the middle. So up to now we have seen deleting a starting node and deleting an ending node. Now we are going to see deleting any intermediate node that we are having. So as an example, suppose consider that I want to remove the 7 here. So initially I am starting at 1. That is, the pointer is starting at 1. Is 1 is equivalent to 7? No, 1 is not equivalent to 7. 1 is not equivalent to 7. So that's why what we are doing, I am incrementing the pointer to the pointer of next, that is 3. Now I will be present at 3. The pointer is present at 3. Is the pointer of data is equivalent to 7? No, pointer of data is not equivalent to 7, it is 3. So pointer is incremented to the next node, pointer equal to pointer of next. Is the pointer of data 4 is equivalent to 7? No, it is not equivalent to 7. So pointer is going to the pointer of next. Now if you see, is the pointer of data is equivalent to 7? Yes, pointer of data is equivalent to 7 because whatever the data that is required for us, it is present in this particular node's data. So now I want to remove this particular 7. So now what we want to do, 4 has to point to the 8 and 8 has to point to the 4. So if this is the pointer, what we want to do, 4 has to point to this particular 8 and 8 has to point to that particular 4, and after removing this one, this is the linked list that we'll be having. This we'll see with an example how we are writing. See here, this is the thing. As an example, we are considering that I am removing the 20. Now, by using the previous mechanism, I have reached the pointer to this particular 20. Now, if this is the pointer, the previous thing will become the pointer of previous. The next thing is the pointer of next. Now, what the thing that we want is the pointer of previous should point to the pointer of next, and pointer of next should point to the pointer of previous. Then I can remove this particular pointer. For this particular purpose, what we are doing, see here, pointer of next of previous is pointing to the pointer of previous, and pointer of previous of next is pointing to the pointer of next. Okay. This mannerism will be similar to that of the analogy that we can consider if a people are standing in a line by holding their hands. Suppose if one person is being removed in the middle, we have to tell to the previous person of us to hold the hand of the next person of that particular line. So similar to that one, if this is the person we want to remove, we are telling that the previous person in the line should now point to the next person in the line. The same thing that we are performing here. We are deleting an intermediate node. See here, we are reading the value of the node which we want to remove. The pointer is starting at start, and we are repeating these two steps while the pointer of data is not equivalent to value. If the pointer of data is not equivalent to value, I am going to the next node. In the middle, if the pointer is reaching to the null, the meaning that whatever the value that you are told to remove is not present in the list. As an example, if you see, suppose someone has asked to remove the 10 in this particular linked list. Is it present? No. In such cases, it will be useful for us. If the pointer is equivalent to null, we are displaying that the element is not found. Then we are doing these two activities. The next node of the pointer is pointing to the previous node. The previous node of the pointer is pointing to the next node of the pointer. Then that particular pointer is removed. That is, we are freeing that particular pointer that we are writing in the form of the function. See here, the function that we are writing is, we are taking the pointer and it is pointing to the start, and the element that I want to delete is the value. I am reading that particular value, and while the pointer of data is not equivalent to value, I am going to the next node. In the middle, if the pointer is null, I am writing that element not found and I am coming out of that particular deletion. Otherwise, what we are doing, pointer of next. That means the next node of the pointer is pointing to the pointer of previous, and the pointer of previous of the next is pointing to the pointer of next, and I am freeing the pointer that is present. After removal, the display on function displays the node that is, after removing that particular node, what is the linked list. Now if you see what are the applications that we are having for the double linked list. So this double linked list can be used in the navigation systems where the front navigation and the back navigation is required. And it is also used in browsers to implement the backward and the forward buttons that we are having. The backward button goes to the previous page and the forward button goes to the next page that we have to visit, or already visited page that we want to go to the forward. And it is also used by various applications to implement the undo and the redo operations. Undo operation, it will erase the existing operation, and the redo operation will perform once again that particular operation. And it can be used to represent the deck of the cards in the games. and it is also used to represent the various stages of the game. Okay.